Good evening, and welcome to Truth Report. I'm Alex Truth, and tonight we are pulling back the curtain on 3 stories that, on the surface, look completely unrelated, but stick with us, because by the end of this broadcast, you're going to see a pattern that should concern every single one of you.
I'm Maya Clarity, and tonight we're covering a groundbreaking Nature study that reveals your diet is literally reprogramming your immune system at the cellular level. A new AI-driven approach to modeling water flow through porous materials that could reshape how we manage underground water resources. And a Google moonshot spin-off called Taara that's beaming internet through the open air with lasers, promising to connect the unconnected. 3 stories. 1 theme: who controls the invisible systems that keep you alive?
We're talking about the air you breathe, the water beneath your feet, and the information that flows into your home. And in each case, new science is revealing that the gatekeepers are not who you think they are. Let's get into it.
Our first story tonight comes straight from the pages of Nature, one of the most prestigious scientific journals on the planet. Published March 4, 2026, a team of researchers has discovered something that should fundamentally change how we think about diet, immunity, and disease. Alex, break it down for us.
Maya, this is a big one. Researchers have found that the balance of fats in your diet, specifically polyunsaturated fatty acids versus monounsaturated fatty acids, directly determines whether your T cells live or die through a process called ferroptosis. That's a form of iron-dependent cell death. And when your T cells die, your immune system can't fight infections, can't fight cancer, can't do its job.
Let's be precise about what this study from Nature actually shows. The researchers demonstrated this in both mouse and human T cells. This isn't just a rodent study that might not translate. They found that when polyunsaturated fatty acids, the kind you find in seed oils, certain fish oils, and processed foods, accumulate in T cell membranes, those cells become dramatically more vulnerable to ferroptosis. They essentially become ticking time bombs, waiting for an oxidative trigger to destroy them.
And here's where it gets really interesting. Monounsaturated fatty acids, think olive oil, avocados, nuts, had the opposite effect. They made T cells more resistant to ferroptosis. So we're not just talking about a vague eat healthy message. We're talking about a specific molecular mechanism where the literal composition of the fats you eat gets incorporated into your immune cell membranes and determines whether those cells survive or self-destruct.
Now, I want to pause here because the implications of this are staggering. For decades, the dietary advice given to the public has been shaped by food industry lobbying. We were told to replace saturated fats with polyunsaturated seed oils, soybean oil, corn oil, canola oil. These oils are now in virtually every processed food on the shelf. And this study is telling us that an overload of those exact fats may be undermining our immune systems at the most fundamental level.
And let's connect the dots. The Western diet, the standard American diet, is absolutely drenched in polyunsaturated fatty acids from processed seed oils. At the same time, we're seeing epidemic levels of autoimmune disease, chronic inflammation, and cancers that the immune system should theoretically be catching early. This study doesn't prove that connection definitively, but it hands us a biological mechanism that makes that connection terrifyingly plausible.
The research highlights a key role for lipid metabolism and dietary composition in regulating T cell function. That's a direct quote from the study's findings. What that means in plain language is that your dinner plate is programming your immune system. Not in some abstract, hand-wavy sense. In a measurable, molecular, life-or-death sense. The fatty acids you consume are physically embedding themselves in your T cell membranes and determining whether those cells can do their jobs.
So who benefits from this knowledge, and who loses? The pharmaceutical industry has built a multi-billion-dollar empire around immunotherapy drugs, checkpoint inhibitors, and other interventions designed to boost or modulate T cell activity. If it turns out that a significant portion of immune dysfunction is driven by dietary lipid composition, that's a direct threat to that revenue model. Why spend $200,000 on immunotherapy if changing your dietary fat profile could make your T cells function properly in the first place?
And who loses? Potentially the processed food industry. If this line of research continues to hold up, and Nature doesn't publish findings lightly, it could force a fundamental reckoning with the seed oil-heavy, polyunsaturated fat-loaded food supply that generates hundreds of billions in annual revenue. We're talking about an industry that has spent decades and millions in lobbying dollars promoting exactly the kind of fat profile that this study suggests may be compromising human immunity.
I also want to flag something for our audience. Pay attention to how this study gets covered, or doesn't get covered, in mainstream health media. Studies that threaten major industry revenue streams have a way of being quietly buried, minimized, or drowned out by contradictory messaging funded by the very industries that stand to lose. If you're hearing about this story for the first time on Truth Report, ask yourself why your usual news sources didn't lead with it.
The broader power structure at play here is the intersection of food policy, public health guidance, and corporate influence. The dietary guidelines that shape what Americans eat are developed through a process that is heavily lobbied by the food and agriculture industries. If the science is now telling us that the specific fat composition promoted by those guidelines may be damaging T-cell immunity, we need to ask who wrote those guidelines and whose interests they actually serve.
Let's move to our second story, and this one takes us underground, literally. A new paper on the AR-14 preprint server describes a breakthrough in modeling how water moves through complex porous materials, and before you tune out thinking this is dry academic stuff, let me tell you why this matters enormously.
The paper is titled Physics-Constrained Symbolic Regression for Discovering Closed-Form Equations of Multimodal Water Retention Curves from Experimental Data. That's a mouthful, but here's what it means. Researchers have developed an AI-driven method to create mathematical equations that accurately describe how water is held and released in materials with complex, multi-scale pore structures, think soils, concrete, geological formations, engineered barriers.
Why does this matter? Because understanding water retention in porous materials is absolutely critical for groundwater management, nuclear waste storage, agricultural irrigation, dam safety, and predicting how contaminants spread through soil. The current standard models, the Van Genupton model, the Brooks-Corey model, work reasonably well for simple materials with uniform pore sizes. But real-world materials almost never have uniform pore sizes. They have multiple scales of porosity, and the standard models fail to capture that complexity.
What this team has done is use symbolic regression, an AI technique that discovers mathematical equations from data, but with physical constraints built in. That's the key innovation. The AI isn't just curve-fitting blindly. It's forced to produce equations that obey the known physics of capillary pressure, pore geometry, and thermodynamic consistency. The result is equations that are both accurate and interpretable. You can actually read them and understand the physics, unlike a black box neural network.
And here's where the investigative angle comes in. The current approach to modeling multimodal water retention, materials with multiple pore size ranges, involves superposing multiple unimodal functions, each one fit separately to a different pore size range. The paper explicitly states this limits interpretability and requires separate parameter identification for each mode. In other words, the current approach is clunky, opaque, and prone to error. This new method produces a single, unified equation that captures the entire multimodal behavior.
Now, let's talk about who needs this and why it matters for the public. Underground water resources, aquifers, supply drinking water to billions of people worldwide. Modeling how water moves through the geological formations that contain those aquifers is essential for sustainable water management. If your models are wrong, you over-extract, the aquifer collapses, and communities lose their water supply. We've seen this happen in parts of California, in the Ogallala Aquifer region, and across the Middle East.
And there's another critical application, nuclear waste storage. Countries around the world are planning to bury high-level radioactive waste in deep geological repositories. The safety case for those repositories depends entirely on modeling how water might eventually contact the waste canisters and transport radioactive materials through the surrounding rock. If your water retention models can't handle the complex, multimodal pore structures of those geological formations, your safety predictions could be catastrophically wrong.
This is a case where better science directly translates to public safety. The existing models that regulatory agencies use to approve nuclear waste repositories, to manage aquifers, to design flood barriers, those models have known limitations with complex porous materials. This paper offers a path to more accurate, more transparent, more physically grounded models. The question is whether the agencies and industries that rely on the current models will adopt better ones, or whether institutional inertia and the cost of revalidation will keep inferior models in use.
And let's be honest about the power dynamics here. The companies and agencies that have built their compliance frameworks around existing models have a vested interest in not changing those models. A new, more accurate model might reveal that a previously approved nuclear waste site is less safe than predicted, or that an aquifer is being over-extracted. Better science is not always welcomed by the institutions that would have to act on it.
The agricultural dimension is equally important. How water is retained in soil directly determines crop yields, irrigation efficiency, and the resilience of farmland to drought. With climate change intensifying drought cycles across major agricultural regions, having accurate models of soil water retention isn't academic, it's a food security issue. Farmers and water managers need tools that capture the real complexity of their soils, not simplified models that work well only in textbook scenarios.
What I find particularly compelling about this research is the marriage of artificial intelligence with hard physical constraints. We're in an era where AI is often deployed as a black box. You feed in data, you get predictions, and nobody can explain why. This team took a different approach. They said, we want AI to discover new equations, but those equations must obey the laws of physics. That's a model for how AI should be used in high-stakes applications, not as a replacement for understanding, but as a tool for deepening understanding.
And the fact that this produces closed-form equations, actual mathematical expressions you can write down, analyze, and verify, is a direct rebuke to the trend of replacing transparent science with opaque algorithms. In a world where decisions about water safety, waste storage, and food production are increasingly being delegated to AI systems that nobody can audit, this research shows there's a better way. Science that is both powerful and transparent. That should be the standard, not the exception.
Now let's turn to our third story, and this one is about the very infrastructure of information itself. According to reporting from IEEE Spectrum, a company called Taara, which spun out of Google X, Alphabet's Moonshot Factory, is deploying free space optical communication links that deliver fiber-optic speeds through open-air laser beams. No cables. No trenches. No digging up roads. Just light, beamed through the atmosphere.
Let's set the scene. Taara's technology uses narrow laser beams to transmit data between two terminals that can be mounted on rooftops, towers, or poles. According to IEEE Spectrum's reporting, these links can deliver speeds comparable to fiber-optic cables. We're talking 20 gigabits per second over distances of up to 20 kilometers. The terminals use advanced optics and tracking systems to maintain alignment even in wind, rain, and atmospheric turbulence.
The original mission, when this was still inside Google X, was connecting rural and underserved communities that lack fiber-optic infrastructure. And the economics are compelling. Running fiber-optic cable costs tens of thousands of dollars per kilometer. You have to dig trenches, lay conduit, navigate permitting, deal with right-of-way issues. Taara's terminals can be deployed in hours for a fraction of the cost. In sub-Saharan Africa, parts of South Asia, and rural areas worldwide, this could be transformative.
And it's already happening. Taara has deployed links in multiple countries, connecting communities that were previously limited to slow, unreliable cellular data or satellite connections. For these communities, high-speed internet access isn't a luxury, it's access to education, healthcare, economic opportunity, and civic participation. The digital divide is one of the most consequential inequalities on the planet, and technology like this has the potential to meaningfully close it.
But, and there's always a but on Truth Report, let's look at this with investigative eyes. Taara spun out of Google X. It carries Google's DNA, Google's vision, and Google's strategic interests. When a company whose entire business model is built on harvesting and monetizing data provides the infrastructure through which that data flows, we need to ask hard questions about what that means for the communities being connected.
That's a critical point. Internet access is not neutral. The terms of that access, who provides it, who controls the infrastructure, what data is collected about usage patterns, what content is promoted or suppressed, these are questions of power. When a Google-affiliated entity becomes the internet backbone for communities that previously had no connectivity, those communities become dependent on that entity. And dependency creates leverage.
Now, I want to be fair here. The IEEE Spectrum report focuses on the technical achievement, and it is genuinely impressive. Free space optical communication has been a research goal for decades, and the engineering challenges are real: atmospheric scintillation, beam wander, fog and rain attenuation. Taara has apparently solved enough of these problems to deploy commercially viable links. That's a legitimate breakthrough in telecommunications engineering.
The technology uses what's essentially a sophisticated laser communication system. Each terminal has a lens, a laser transmitter, and a photodetector, along with precision tracking systems that keep the beam aligned despite environmental disturbances. What IEEE Spectrum highlights is that these links can now achieve the reliability and throughput that previously required physical fiber-optic cables. For telecommunications engineers, that's a paradigm shift. For the communities it connects, it could be life-changing.
But let's zoom out to the geopolitical dimension. The race to connect the world's unconnected populations is not just a humanitarian effort, it's a strategic competition. Whoever provides the infrastructure controls the gateway. We've seen this play out with China's Huawei building telecom infrastructure across Africa and Asia, with Elon Musk's Starlink satellite constellation, and now with Google's Taara. Each of these represents a different model of connectivity, but they all share one thing in common: they create dependency relationships between powerful technology companies and the communities they serve.
And here's a question that rarely gets asked: what happens when the business model changes? What happens when Taara decides a particular community isn't profitable enough to serve? What happens when the terms of service change, or when the data harvesting policies evolve? Communities that have built their digital economies around this infrastructure can't simply switch providers. The switching costs are enormous, both technically and economically. This is the classic platform dependency trap, applied to fundamental communications infrastructure.
I also want to highlight the surveillance implications. Laser communication links, by their very nature, route all data through centralized terminals. Unlike the distributed, redundant architecture of the traditional internet, a free space optical link is a single point of control, and a single point of surveillance. Every packet of data flowing through that link can be monitored, logged, and analyzed. For communities in countries with authoritarian tendencies, this is not a theoretical concern.
To be clear, we're not alleging that Taara is conducting surveillance. What we're saying is that the architecture of the technology creates that capability, and when you're deploying communications infrastructure in countries with varying records on human rights and press freedom, the architecture matters as much as the intention. The question isn't whether Taara will abuse this capability, it's whether the safeguards exist to prevent anyone from doing so, now or in the future.
And that brings us to the synthesis, because these three stories, T-cell immunity and dietary fats, AI-driven water retention modeling, and laser beam internet links, are all telling us the same thing from different angles. They're all about invisible systems that govern fundamental aspects of human life, and they're all revealing that those systems are more manipulable, more controllable, and more consequential than most people realize.
Think about it. Your immune system is being shaped by the lipid composition of the food supply, a food supply controlled by a handful of corporations whose products are loaded with the very fats that this nature study links to T-cell vulnerability. Your water security depends on mathematical models that may be inadequate for the real-world complexity of the geological formations they're supposed to describe. And your access to information is increasingly mediated by infrastructure owned by technology giants with their own strategic agendas.
The common thread is control through invisibility. Most people don't think about the fatty acid composition of their cell membranes. Most people don't think about the mathematical models used to assess the safety of their drinking water aquifer. Most people don't think about who owns the physical infrastructure through which their internet traffic flows. And that invisibility is what allows these systems to operate without accountability.
The Nature study on ferroptosis and T-cell immunity is a perfect example. The research has been published. The mechanism is clear. But watch what happens next. The processed food industry will fund counter-studies. The dietary supplement industry will rush out products. The pharmaceutical industry will look for drug targets. And the simple, actionable insight that your dietary fat profile directly impacts your immune function will be buried under an avalanche of conflicting messages designed to preserve existing revenue streams.
The water retention modeling paper shows us the flip side: what happens when better tools are available but institutional inertia prevents their adoption. Regulatory agencies move slowly. Updating the models used in safety assessments requires years of validation and political will. Meanwhile, decisions about nuclear waste storage, aquifer management, and flood protection continue to be made using tools that the scientific community knows are limited. The gap between what science knows and what policy does is where public safety falls through the cracks.
And Taara's laser links show us the future of infrastructure control. The next billion internet users will come online through systems built and operated by a small number of technology companies. Those companies will shape what those users can access, how fast they can access it, and on what terms. The promise is connection and empowerment. The risk is dependency and surveillance. And the communities being connected rarely have the leverage to negotiate the difference.
So what do we do with all of this? First, demand transparency. The Nature study should trigger a public review of dietary guidelines and the role of industry lobbying in shaping them. The food we eat should not be compromising our immunity because it's cheaper for manufacturers to use seed oils than olive oil.
Second, demand that regulatory agencies adopt the best available science. When better models exist for assessing water security, nuclear waste safety, or environmental contamination, the public has a right to expect that those models are used, not shelved because updating them is inconvenient or expensive. The AI-constrained symbolic regression approach described in that AR14 paper represents exactly the kind of transparent, physics-grounded modeling that should be the gold standard.
Third, demand accountability from the companies building the world's communications infrastructure. Whether it's Taara, Starlink, or anyone else, the communities being connected deserve to know who controls their data, what happens to it, and what safeguards exist against surveillance and censorship. Connectivity without accountability is just a different kind of control.
And finally, pay attention to the stories that don't get covered. The T-cell ferroptosis study, the symbolic regression paper, the details of how Taara's technology actually works, these are stories that don't fit neatly into partisan narratives or clickbait headlines. But they're the stories that actually determine the conditions of your life. Your immunity. Your water. Your information. These are the systems that matter, and they operate best for those who control them when you're not paying attention.
That's exactly right. The purpose of Truth Report has always been to make the invisible visible, to trace the connections that others ignore, and to ask the questions that the powerful would rather you didn't ask. Tonight we've shown you that the food you eat is programming your immune cells for survival or death, that the mathematical models protecting your water supply may not be up to the task, and that the promise of universal connectivity comes with strings attached that few are willing to discuss.
If these stories matter to you, and they should, share this broadcast. Talk about it. Look up the sources yourself. The Nature study is freely accessible. The AR-14 paper is open access. The IEEE spectrum reporting is available to anyone with a browser. The information is there. What's been missing is the willingness to connect the dots and say plainly what it all means.
For Truth Report, I'm Alex Truth.
And I'm Maya Clarity. Question everything. Verify relentlessly. And never, ever stop demanding the truth.
Good night.